Networks exam practice question 6. What is the shortest path between A and D? So we need to make sure we are starting at A, and we need to go to D. So I'm just going to mark those 2 points, A and D. So from here, I always think about the shortest path to get there. So straight away, I look at it from A at the moment. I can go 5 or I can go 9. And 5 is the shortest. Likewise from D. D I can go 11 or I can go 7. And then I've just got 13 between both of them will be the shortest overall. So that gives me the shortest path where all I need to be doing is going distance of 5 plus the distance of 13 plus the distance of 7, and that equals 25. B. The length of Euler's path for the graph. So the first thing I need to think about is it's a path, not a circuit, which means there should be 2 points with odd degrees, and I've got A and I've got B. So that will be my start and end point. So if I'm thinking about my Euler's path, I need to cross every single point, which means I'm going to be adding up every edge. So that means I am going to be going 15 plus 11 plus 7 plus 14 plus 9 plus 12 plus 13 plus 8 plus 9 plus 5. And this equals 103. Part C is the length of the shortest Hamiltonian circuit. Now, if we are talking about a Hamiltonian, straight away we are talking about going through all of the vertexes. But we would like it to be a circuit. So the first thing I think about is I always pick two spots. So one vertex. So I'm straight away just going to be picking A. Now I've picked A, the next thing is thinking about what is the 2 sides that are the shortest. Well, I've got B, and I've also got A to F. The next thing I look at again is what is the shortest. Well, I could go 12, or I could go to 9, and 9 is the shortest. Again, 14 to C, but I need to get to D, and that is the shortest. And I'm doing the shortest from D to C, which is 7. Now I just need to continue back to B, and that gives me my circuit. Now I've got a circuit, I just need to add those amounts up, and that is 5 plus 9 plus 9 plus 11 plus 7 plus 13, and this equals to 54. Okay, and last part, D. The length of the minimum spanning tree is. So the first thing is a spanning tree is building, connecting all of its vertexes together, but with no loops, no multiple edges, and having them joined with the shortest amount of size. So I'm just going to pick one, which is B. But to get A, the shortest I can go from E to A, 15, F to A, 9, or B to A, which is 5. Likewise, if I'm wanting to go from B to F, 8 is the shortest. As I'm looking at this now, I can see I can go to E with 9, or 14, or 11, and 9 is the shortest. So the next thing I need to think about here is another short side that I'm going to use is using D. I would much rather connect D to C because of it's 7. The last side I need to connect is I need to connect C with the rest. So I need to either pick 13, 12, and 14, and C to F is the shortest of 12. So now I just need to calculate the length of the minimum spanning tree, which is 5, plus 8, plus 12, plus 9, plus 7. And this is where sometimes we make a mistake, because I just realized that I'm going to take away that length from C to F, and I'm going to put in 11. Because what I'm going to do, I'm going to change my tree because it's not the minimum yet. And this is where we need to always double check. So I'm going to put that black line back in. And I'm going to join up E to D. Because that ends up being shorter. Because E to D is 11, whereas C to F is 12. And that gives me the grand total of 40. So the minimum length is 40.